In the continuation of solving the problem, let us solve another problem related to the paging technique. So here this question is given, and the question says that consider a system with 36-bit logical address, 32-bit physical address, page size equal to 4 KB. So what is given here is we have the logical address which is given 36-bit. Then we have the physical address which is given 32-bit, and the page size which is given is 4 KB. Each page table entry contain two protection bit, right? One valid invalid bit and one modified bit along with frame number. So we know this from the page table entry, and in the page table as we have known. So first thing that will be there is the frame number, right? And then we have five optional bits or five optional uh, information. So it says that there are some additional information, that is two protection bit instead of protection bit as a 3, we have the two protection bit. So this is of 2-bit, which is of protection bit. Then we have one valid or invalid bit and one modified bit, which is a dirty bit also called, right? Valid invalid, which is also called what? Which is there, here or not, is a present or absent bit, right? So and this one is the protection bit. So read write and write read protection in that way. So this is the entry, this is one entry, it is equal to E. So that size we required actually, along with the frame number. So frame number is there. What is the page table size? So I want the page table size. So what is the formula for page table size? We know that the formula for page table size is number of pages into one entry size, right? One entry size. So for that, what we required is we required E and we required N. Let's calculate E first. How will calculate E? So to finding E, we have to find out the F. What is F? F is the frame number or frame number bits. So how we'll get it? If we'll get the number of frames. And how we'll get the number of frames? M will get the number of frame M by the physical address space and divided by the number of frames. So it is physical address space divided by the or the frame size. What is the frame size, right? So physical address space, how we'll find out physical address space? This is the physical address space. Physical address space will be calculated as 2 to the power of physical address. And what is 2 to the power of 32 word or bits or bytes, sorry. That is my physical address space. So it will be 2 to the power of 32. And then we have the frame size. So frame size is equal to the page size. So page size is given. So what is the page size? Page size is 12 KB. So it is 2 to the power of 32B, and it will be 4 KB. So 4 into K, it will become 2 to the power of 10, right? And this will become 2 to the power of 32 divided by 2 to the power of, this is 2 to the power of 2 into 2 to the power of 10. It will be 2 to the power of 12. Means total it will be 2 to the power of 20. So how many bits we required? We required 20 bits. So this will be 20. So this is 20 plus this is 2 plus this is 1 plus this is 1. How much it is? It is of 24. What? 24. 24 bits. So E means your entry size is 24 bit, and when we convert it to byte, it will become 3 bytes, right? If we'll convert 24 bits, it will become 3 into 8 bits. So because 8 bits is the byte, so it will become 3 bytes. So E we got, right? E we got. Now the next is we have to find out N. What is N? N equal to, so we find out M. So now we'll find out N. What is N? N equal to logical address space divided by page size. So what is logical address space? It is of 36 bit. It will become 2 to the power of 36. This is a logical address. What is the logical address space? It will be 2 to the power of 36 word or byte. Right, 2 to the power of 36 divided by 4 kb. 4 kb, what we got is 2 to the power of 12. So it will be how much? 2 to the power of 23. Sorry, this is of, in the question it is written 35, not 36. In the question it is written 35. So it will be 35. Now it will become 23. Now we got it 2 to the power of 23 that we got. So it will become, what is 2 to the power of 23? So 2 to the power of 3 into 2 to the power of 20, right? So what is 2 to the power of 3? It will become 8. And 2 to the power of 10, it will become m. So 2 mb. Now we'll calculate this. It will become 8 mb into, what is E? E is 3b. So what is the total one? So total one will be 24 MB is my answer. 24 MB is my answer. 8 into 3 it will be 23. Sorry, 8 into 3 it will be 24 M and byte. So it will be the answer. What is the answer? 24 MB is the page table size in bytes we require. So I think you understand. Now let's go to the next question. Then the next question says that a computer system implements 8 KB pages. So it is showing 8 KB pages. It means the page size. It is giving page size. Page size is 8 KB. 32-bit physical address space. What is a physical address? Physical address is 32-bit. So physical address space, we can find it out, right? Each page table entry contain valid bit or invalid, that is there, dirty bit, 3 permission bit. So let's draw the frame again, draw the page table entry again. This is frame number, frame is there. Then we have the valid, invalid bit. Then we have the permission bit is there. And the last one is the dirty bit. So for valid invalid we have required only 1 bit. For permission it says 3, so it is 3, and for the dirty we have 1. So we have how much? 5 plus frame. how will get the frame? So to finding out the f value, that is frame value. So in this, how we'll find out the frame value? By this, right? So we should have the physical address space divided by the frame size. So we'll go to the same way. This is m. I will find out the m. It is just the physical address space divided by the frame size. So what is the frame size? Frame size is equal to the page size. It will become 8k, 8 into 2 to the power of 10, right? And physical address space is given is 32. 32 means 2 to the power of 32. So we have 2 to the power of 32 divided by, it will become 2 to the power of 3. It will become, so it will become 2 to the power of 13. So now that is 2 to the power of 18. Sorry, 2 to the power of 19. So 19 is my frame bits, right? So it will be 19. So how much is the total? Total it will become 24 bits. So this is 24 bits. If we'll convert into byte, it will become 3 byte. So 3 byte we find out here with the e value. So this is the e value. This is the e value that we find out. Now let's talk about what is the next thing that we have to. If the maximum size of the page table is 24 MB, so the page table size has been given. What is the page table size? So what is the formula for that? Page table size equal to number of pages into entry size. So page table size is given as 24 MB. And n, how we'll find out n? N is nothing but logical address space divided by page size, and the entry is e, right? Now let's calculate logical. Could we get logical address here? What it is the question? The question is the length of virtual address supported by the system is how many bits. So what we required, what is the answer it is looking for? It is looking for the answer of virtual address is nothing but your logical address in bits it is requiring, right? So if we'll get the logical address space, we can find out the logical bits, right? So let's do that. This is 24 MB. Logical address space, I don't know. Page size, I know that is 8K. 8K will be, okay, I'm writing like this. And this is E. E is 3 byte. So it will be 3 byte, right? Let's try to solve it. Now logical address space will become 24 MB into 8 KB divided by 3 byte, right? So it will become 24 MB. 24 means it will become 2 to the power of uh, this is 2 MB. This is MB. This is KB. MB into KB it will become GB, and 24 into 8 it will become how much? So we can make it like 3 8. So it will become 8 byte. Okay, so it will become 8 into 8 it will become 64. M and K it will become GB. 64 GB is the answer for logical address space. And the logical address space is 64 GB. Now how we'll find out the logical address? It will be upper bound of log 2 of logical address space. So what is logical address space here? So logical address space here, it is saying that 64, it means to the power of 6 into to the power of 30 byte. That will apply here. It will become log 2 to the power of 36. So it will become 36. So 36 bit is the logical address space. Logical address space is 36 bit. The answer is 36 bit. Getting it? How will get logical address space? Logical address is nothing but 36. What is logical address space? Is 2 to the power of 36. What is 2 to the power of 36? 2 to the power of 6 into 2 to the power of 30. 2 to the power of 30 is GB, and 2 to the power of 6 is 64. So 64 GB we are getting it, right? So this is how we'll calculate the different parameters in the paging technique.